Number 16. For this function f of x, apply the leading term test to determine and write the end behavior of the function. So this is in factored form. As a reminder, to find the leading term, it's just usually in standard form, it's really easy to identify. If it's in factored form, what you do is you multiply any value that is connected or has an x. So here I'd be multiplying x with 4x and x, but don't forget that it's actually x squared here. So it'd be like x times 4x times x squared. Is basically what I multiply for my leading term test, and so I'll actually move this down here. And so when we multiply this out, I have x times 4x is 4x squared times x squared gives me 4x to the fourth. Now what does this tell me? Since it's even power, we know that this will look like a u. It'll be reflected over the y-axis. It's an even function. Not only that, because the 4 is positive, it will go up in the first quadrant and also up into the fourth. So we'd have a graph that's going to look something like this. Now we don't know exactly what the middle will appear with like. This part could be all kinds of things. That's why I do a squiggly line, but we know that it's going to go up and to the right and up and to the left. So to determine the end behavior, which behavior again means limits. So we're going to write a limit here. You would ask yourself, like, what x value and y value is this arrow approaching? Well, it's going left forever, and which is negative infinity. It's going up forever, so positive infinity. This arrow is going right and up forever, so it'd be positive infinity and positive infinity. To write these as a limit, you always have lim. They name this function f of x, that's the limit that the y value is approaching as x approaches different values. So as x approaches negative infinity here, the y value it's approaching is positive infinity. That goes next to f of x. So I would do this again. The limit of f of x equals as x approaches. So this time, as it goes right, which is positive infinity for the x, the y value goes up to positive infinity. This is the answer for part A here. And we got this from the leading term test, and the leading term is this value right there. That's the leading term. Okay, part B. So once you got that, it says determine the zeros and state the multiplicity of any zeros. So given this function, we can state the zeros really quickly. What was it? 4x minus 5 and x plus 3 squared. Did I get that right? Okay, I did. This has zeros if you set it x equals 0 like this. That would mean x equals 0. This is going off the zero product property. If you're multiplying and you have a product of 0, the only way to get 0 is that one of the factors, at least one of the factors, must equal 0. So here, x is by itself, so x would have to equal 0. Here, you would solve for x, and you would move the negative 5 over, and it become positive 5. Then you divide by 4, so you'd have x equals 5 divided by 4. Again, how I got that is I would say that 4x minus 5 equals 0, like that. Kind of what I was doing right there. And then you would add the 5 over, so 4x would equal positive 5. And then you could say x equals 5 over 4 when you divide by 4. Finally, the last one, you just move this across, and so x plus 3 equals 0. You have that x equals negative 3. Since it's squared, this would be multiplicity of 2. And so here would be our answers. We have this one, and this actually counts as 2 zeros. Now part C says find f of negative 1. So I take this same equation that I just had up there, and this time to find f of negative 1, what I do is I can plug in negative 1 all the way across for x. Or you could do synthetic with the value of negative 1 as well, but I'm just going to plug this in like that. Okay, so do a little PEMDAS here. I'll simplify these parentheses, and this would be negative 1 times this becomes negative 4 minus 5. This becomes 2. And to simplify this parenthesis again, I'd have negative 1 times negative 9 times, and 2 squared is 4. So negative 1 times negative 9 becomes positive 9 times 4 equals 36. So f of negative 1 equals 36. That's the answer to part C. And now part D asks us to graph the function. Obviously, I can't get 36 on the graph, which is unfortunate. But what I can do is put some of these other values on there. We know that the x, we have zeros at here. We have 0. We had, what, 5 over 4. 5 over 4 is 1.25. This one is -3. 1, 2, 3. We know since it's multiplicity 2, this will be a parabola, and since we know it's going up on each outside, this value here will go up this way, like that. And we know this one's going to go up this way, like that. We got that from the end of the leading term test. Now, since this has a multiplicity of 2, it curves this way, like a parabola at that spot, and we also know that f of -1 is 36. So let's just say these count by 6. If these were counting by 6, this would be 6, 12, 18, 24, 36, 30, and I'd have to go to 36 right up there. So this is going to go off the graph with f of -1, values there. So I'm just going to kind of come up. I don't know exactly what it'll look like, but I'm just going to make it go down like that to this point. I don't know what f of 1 is, but I'm just going to kind of go like this through. That's going to be the general idea of what the function would look like. We did all that without the calculator.